I'll talk about this first, and then I'll talk about this one. The Andromeda Galaxy looks really weird. Is something that I found out in a recent video I watched. That the Andromeda Galaxy's formation looks like a lot of its like solar systems or whatever that are in it are in some kind of like cone formation. Like the farther out they are, the more they're getting pulled towards seemingly our galaxy, the Milky Way galaxy. And it's kind of interesting to see this, and it's very puzzling to astronomers, from what I understand. And my theory on this is that basically, they say, they shouldn't, they shouldn't be doing that at such great distances. But I think that the fact that the Andromeda Galaxy is heading towards us, I think I did talk about this before, is because that the pull of gravity along those distances, like the distance, the mass of the Andromeda Galaxy and the mass of the Milky Way galaxy is large enough for there to be some, like, for the equilibrium point between the two of us to not have been reached yet. I don't think that we will necessarily collide with the Andromeda Galaxy, but I do think that we will enter into some kind of twin orbit if we haven't already done that. So I think there will be points that we will not be alive to see, most likely, where eventually the Andromeda Galaxy will head towards us, and we'll either get locked into a sort of orbit around each other at some distance. Probably won't be all that close, to be honest, but at some distance, we'll get locked into this kind of twin orbit around each other, and then so either we'll move towards each other, and as soon as that happens, basically it'll be, I think the Andromeda Galaxy is larger than us, so it'll be like they're the Earth and we're the moon, and we get locked in this kind of orbit going around them. Or what could happen is that it'll fly past us, right? Or we'll fly past it, depending on how you want to look at it, right? And again, it won't be all that close, but we'll fly past it, and then it'll look like it's going away from us again. And then after a long time, right, it will then seem to kind of stop and come back towards us. And it, again, since it's larger, it may be more practical to look at it as we're orbiting the Andromeda Galaxy rather than the Andromeda orbiting us. But I think if we're not already in some kind of orbiting pattern with the Andromeda Galaxy, I think that is what is the inevitable outcome. Not that we will be able to find that out, because there's no way we will be alive then, or at least I won't be. So, as it approaches us, I think that we're either, like I said, either already in that scenario and it just is now coming back, or we will be in that scenario where we start this kind of orbiting elliptical pattern. And the shape of the Andromeda Galaxy, getting back to what I was initially talking about, is this weird kind of cone shape facing towards us. And they say that this is kind of weird, but to me this makes sense, because if the pull between the galaxies, right, is, if you imagine a line in between us and Andromeda, and the pull in between, the gravitational pull is strong enough to, that there's an imbalance in what I'm going to call the the cosmic. I'm just coining this off the top of my head. I don't know, cosmic return rate, right? The rate of which dark energy is replenishing in between is being outmatched at this point. The effect of gravity is strong enough to reduce the rate of time enough to reduce the rate of replenishment enough to cause an attractive force between these 2 points. And so as it's getting pulled towards us, right, it may be um, it may be that, we have a similar appearance in our galaxy that we just haven't been able to necessarily observe because we're in it, so it's harder to see the correlation. I'm not sure. This is a pretty recent study from my understanding, so maybe there just hasn't been enough looking into it to realize any other similarities. But this weird cone shape does make sense because the points that should, be less affected by the gravity should be the center, right? And the points on the outside should be easier to pull away because they have less kind of other things holding them in place. So these outside clusters, outside either galaxies or solar systems, should be being pulled on by our galaxy more and should be farther, like farther pulled out than the center. And so this cone shape to me makes a lot of sense with how I kind of see gravity and, my idea of everything. So to me, this makes a lot of sense because the center should be, the center, and then outside of it, it should slowly kind of spread out as, the gravity is less and less effective. So it is kind of interesting to see that. And when I saw that video, I thought that was very interesting because I was like, well, that does kind of track, I think, with what I think. So, potentially another point for me. But I did want to talk about that because I guess I never wrote it down as something to discuss, but I did want to discuss that. And then going into my next thing, a lot of people talk about how our sun or stars in general, are just competing with gravity to stay burning. But I don't think that this is the right idea to have. Stars are not competing with gravity to stay burning. They create gravity. They are using gravity to burn in the first place, right? That's I think that it's kind of like a misconception that it's like this great struggle to fight out against gravity to stay alit, but without gravity a star doesn't exist, right? So I don't know if it necessarily makes sense to say it's this great struggle or great battle. I feel like it's kind of this misunderstanding here. There isn't a struggling against gravity. They are using gravity. If gravity weren't beneficial to matter, why would it bunch up? I feel like this is like a weird but valid thing to say. If gravity is this thing that stars are constantly fighting against, why would stars even exist in the first place? I don't think, I think the problem we look at it is like, oh, a star burns and then it dies and becomes like a neutron star, and then it becomes a black hole or something along those lines. Like, how is that a failure? If it becomes a black hole, that's the ultimate success. It's a point of, as we say now, people say, oh, singularity can't be a thing. That's probably not true, but I think that it is true. And so the grand goal of a star is basically to become a black hole, because at that point, you've kind of won the game. You've become this point of nearly perfect consumption, right? Turning nearly pure profit, right? And it's maximized its lifespan, because if you think about how long it takes for a black hole to die, it's forever. Not literally, but right. So I don't think that we should necessarily look at this collapsing of a star as a failure on the star, or the star falling apart. I think it's, the ultimate goal the star is heading towards. The star isn't trying to burn brightly. It's trying to consolidate its mass to maximize its gravity, to maximize its internal energy, to a point where it, can do something. And if a star isn't big enough, some stars go supernova or whatever. I actually don't know exactly what the circumstances are that cause that. Do they go supernova and then become white dwarfs? Or do they completely annihilate themselves in a supernova? I'm not totally certain. But if stars don't just completely explode, which I don't think they do, then that sending out of energy is not a failure on their part. They're rebirthing more. It gives the potential for more stars to form, and things along those lines. While also because basically they don't need that energy anymore. They don't need that, right? But I got on a tangent there. Um, um, Gravity isn't separate from matter. Matter creates gravity. It is like saying that like we constantly have to fight against eating, right? That it's like a great struggle to continue eating. Um, it's not this hard task. Oh, I have to eat again. Oh gosh, it's like we eat to keep ourselves alive. Um, if you stopped eating, you'd just die, right? So I think it's the same thing for a star. To turn off its gravity, it would just die, because again, stars don't exist without gravity. Um, but I just think it's kind of a misconception to think that, or to phrase it as like a star dies. I don't. That's like saying when a baby can walk, it's died because it's no longer a baby. Or like when a baby can talk, it's died because it's no longer a baby, right? No, it's just gone on to the next phase, the next step in its evolution. And you can say an adult is capable of doing, all these great things, but you could also look at it and say that, it's slowly aging and eventually it's gonna die, right? A person eventually dies. Well, so does a black hole, but it's gonna take a long time, and it can do a lot in that time, just like an adult human can do a lot in that time. And it's not that a star or a child can't do anything. It's just they're not as capable as they could be when they are larger, or older. So, yeah, I just wanted to kind of put that out there and make that point that I think looking at the life cycle as a star, as a death, isn't necessarily the right way to look at it, and seeing its evolution and its existence as this struggle against the fundamental forces of the universe is not necessarily the right way to look at things. Right way to look at things either. But yeah, that's about it. So, peace out.